Entonces, continuamos con nuestro programa. Vamos con la última plática de esta sesión 3 y tengo el gusto, el honor, el placer de recibir nuevamente a la doctora Morgan Robles, quien nos dio ayer una plática muy interesante de un tema muy complejo. Welcome, Dr. Morgan, here again. It's a pleasure to have you with us. Me voy a permitir revisar nuevamente su currículum por quienes no hayan podido estar en la sesión de ayer. La doctora Morgan Robles trabaja actualmente en el Instituto Nacional de la Investigación Científica en Laval, Canadá. Su trabajo de investigación versa sobre los efectos del estrés materno, la ansiedad y la depresión en la función placentaria y el desarrollo de la descendencia en humanos. Ella es maestra en ciencias en fisiología del ganado por la Universidad de Rennes en Francia y tiene obtuvo el doctorado en el Instituto Nacional de Investigación Agronómica, el famoso INRA francés, trabajando sobre la nutrición materna y el metabolismo durante el embarazo en la función placentaria y la salud de los potros. Sus estudios de postdoctorado los realizó en los efectos de la transferencia de embriones y la paridad materna en el desempeño del salto. Tiene además experiencia de investigación y desarrollo en Reverdy, en nutrición equina en Francia. Y está a cargo del desarrollo de una nueva granja experimental y de la comunicación científica. Su plática del día de hoy es la programación del crecimiento de los potros y su relevancia para la industria de la nutrición equina y la alimentación de los caballos. Welcome again, Dr. Morgan. It's a pleasure to have you with us.
Thank you very much again for the introduction and good morning, everyone. So today I will continue to talk about what I talked yesterday, but I will really focus on the horse. So my presentation is entitled Programming the Foal's Growth, Important for Equine Nutrition Industry and Horse Feeding. So just to start from what I said and what other conference people said yesterday, the developmental origin of health and disease stipulates that the modifications of the maternal environment that can be because of nutrition or poverty or obesity, for example. We have a lot of different ways of changing the maternal environment. So I just choose those three. Can lead the fetus to adapt to the fetal to the environment, so it will adapt its own development to this environment, and these adaptations will be because also that the placenta will adapt also to the maternal environment and will be the programming agent of the fetal development, and these adaptations will be. We can see them at the phenotype level, but it will start at a very, very, very tiny molecular level from the epigenetics. And all these adaptations and these changes in fetal development during the in utero life will lead to an increased risk of pathologies at adulthood. So what are those non-communicable chronic pathologies that we can have in the horse? You can have, so the ones that interest us are the metabolic disease, because with obesity being more and more prevalent in the horse, the risk of metabolic diseases is also more and more prevalent. And we have a lot of problems, for example, with the laminitis or the metabolic syndrome right now. We can have also skin disease such as dermatitis. We know that obese horses are more prone to have dermatitis than non-obese horse, for example. osteoarticular diseases also, such as osteochondrosis and arthritis. Digestive diseases, like we know that colic and ulcers are a big problem in horses. Cardiovascular diseases, respiratory diseases, like with the exercise horses, athlete horses, we have a lot of problem with asthma too, and also reproductive diseases and infertility, for example. So during my talk today, I will mostly focus on the metabolic diseases, the osteoarticular and disease and the reproduction function, because other diseases have not been studied in regards to the maternal environment, actually, in the horse. So I will, like, very, very recently, we wrote review called Nutrition of the Broodmare that has been published in Veterinary Clinics of North America, Equine Practice. I used this review to build my presentation. If you're interested, it's here. And if you want a link to have access, you just write me an email and I will send it to you. So first, I will talk about the broodmare's physiology and the fetal placental development for you to really understand what's going on during pregnancy and how the fetus develops during the pregnancy in the horse, and also in regards to the critical periods of development that I presented yesterday. Then I will talk about how energy intake, macronutrients, and vitamin and minerals can affect the development of the foals, the long-term development of the foals. And then we'll have a part on how to assess the adequacy of the maternal environment, what are the tools that we can use to check if the maternal environment is good or not. And a very small part to show you that there is an interaction between the environment, how the mare is, and the nutrition. So first, the broodmare's physiology. So broodmare physiology and metabolism, especially during pregnancy, is not the same as a non-pregnant animal. So here you have changes in plasma, glucose, and insulin concentration after a meal for mares. So here are mares that are not pregnant. So after a meal, normally you see an increase in glucose and increase in insulin blood concentration in the blood after a meal. If the mares are pregnant in what we call early pregnancy, but it's more like early to mid pregnancy, you can see that the increase in glucose is very, very much bigger, and the increase in insulin is also much bigger than for a non-pregnant animal. So it means that in early pregnancy, the mares will have an increased glucose storage in their adipose tissue and liver and muscle. So they will store the energy that they eat. Why? It's because at the end of pregnancy, you see that the increase in glucose absorption is still something like mares in late pregnancy have an improved glucose absorption than mares in early pregnancy. But the difference in insulin release, like there is no difference in insulin release. And also we see a decrease in insulin sensitivity. It means that the mares are less able to store the energy in their own body. They will actually, instead of storing it in late gestation, they will send it to the fetus. It is known that in late pregnancy, the uterus will send 75% of the glucose that is in the maternal blood to the fetus. So in early pregnancy, the mares build the stores, the glucose storage, the energy storage, and in the late pregnancy, they will send all the glucose to the fetus that has a very, very high demand in glucose at that time. And to continue to have enough energy to survive and live, the mare will mobilize the lipids that she stored in early pregnancy and also proteins if she's not fed with enough proteins. So now just talk a little bit more about what is the horse placenta. So the horse placenta is interesting because you have actually two kinds of placenta during the pregnancy. You have first a transient invasive placenta. So it's called the chorionic girdle because it looks like a belt, and the chorion is the tissue that is the part of that creates the placenta. And this placenta appears from 30 to 140 days after ovulation. mainly its main role is to produce the equine chorionic gonadotropin that is involved in the maintenance of pregnancy. It's the main role of this first placenta that appears very early and disappears at 140 days of gestation. And then you have the definitive non-invasive placenta. This placenta appears around 40 days, 40 days of gestation too, and will stay during the whole pregnancy. So as I said yesterday, in the horse, you have six layers of cell that separate the maternal blood from the fetal blood. And in these 6 types of cells, you have one type that is very important, which is called the trophoblast. And the trophoblast is the layer that is at the very end of the placenta, like close to the uterus. It's the one that is the last layers that is against the uterus wall. And you have 2 types of trophoblasts. The first one is called hemotrophic, because it's involved in the nutrients exchange between the maternal and the fetal bloods. So in the horse placenta, you have what it's called microcotyledons. It looks like a little bit of trees. It's a villi that will increase the transfer, like the fact to have villi, it increases the transfer between, like the surface between the maternal and the fetal side. So this hemotrophic trophoblast is along the microcotyledons and is involved in the exchange from the maternal to the fetal bloods. And then you have things like that that are called areoles, and that are a hole that will give to the uterine glands. And it's another kind of trophoblast that will be here. And this trophoblast is called histotrophic. Histo comes from tissue, and trophic comes from food. So it's involved in the nutrients exchange from the uterine gland secretions. So the fetus will be fed through 2 different origins of the nutrients. First, the maternal blood, and secondly, the uterine gland that will secrete a lot of nutrients also, that will also be transferred to the fetus through the placenta. So here you have another example of what the placenta in the horse looks like, with the two trophoblasts. So the one that is involved in the exchange of the blood, the nutrients from the blood, and the one for the nutrients from the endometrial glands. And here is a picture from our laboratory that shows 3D of the equine placenta with all the microcotyledons. So all those villi are microcotyledons. So now there have been a lot of studies that have been performed on how the horse develops and what is the organogenesis of the horse during the pregnancy. But unfortunately, often it's performed on stillbirth or aborted horses. So we might not know exactly the perfect times, but it's still a good idea of how it works. So first, the placentas, they appear at 30-40 days of pregnancy. It means that before that time, the embryo is not implanted in the uterus. And so it will only be fed by the nutrients that will come from the endometrial gland secretions. From that time, the transfer from the maternal blood will start to be put in place and will continue until birth. The horse placenta is very, very special because it continues to grow during the whole pregnancy. So it can adapt pretty well compared to other species, because you will have the placenta and the microcotyledons, they will grow during the whole pregnancy. Then just a very few examples. If you want to see more into details, I did a very detailed figures in the review. So for example, you can see that the pancreatic acini and islets, so really the parts of the pancreas that will later on produce insulin or other hormones, they are formed from the 50 days after ovulation. The liver is completely formed after 40 days of pregnancy. The bone cells and And the articular cells are observed from 30 days after pregnancy. And you can start to observe the smooth cell muscles observed in the gut and the vessels from 30 days of pregnancy. So this first part, so until 35 days of pregnancy, we call it the organogenesis, and it's an embryo. After 35 days of pregnancy, we call that a fetus. So we consider that during the first 35 days of pregnancy, you will have almost the complete organogenesis of the embryo. And it's very interesting because it's at the same time that the endometrial secretion will be the main source of nutrient for the embryo. Then you can see that it's not really organogenesis that will occur, but maturation of the organs. And you have to wait until 255 days of pregnancy to see that the pancreas will start to produce insulin in response to glucose in the fetus. From day 100 of pregnancy, the liver will be an active site of hematopoiesis. The vertebral ossification will start at day 50 after pregnancy, and you will be able to identify the major muscle groups from day 105 of pregnancy. So all that second part of pregnancy, the fetal nutrition will be controlled by the placenta from both the maternal blood and the endometrial gland secretions. So in summary, in early gestation, the male will store energy as fat or glycogen in the liver, the muscle, and the adipose tissue, which coincides usually with the high nutrient quality of pasture if the mare is bred in season, in spring, for example. The endometrial secretions will be the main source of nutrients for the embryo during the first 40 days of gestation. And most of the embryo organogenesis is completed by day 35 of pregnancy. In late gestation, the glucose will preferentially be transferred to the fetus. The male will use her own energy stores to meet the fetal needs and her own needs. So the energy stores that she built during early pregnancy. And the fetal nutrition will be from both the maternal blood and the endometrial secretion. And we will see an organ maturation and a growth, and especially during the 3 last months of pregnancy, you will see an exponential growth of the fetus that will coincide with the increased transfer of fetus from the mother to the fetus. So now I will talk a little bit about undernutrition, overnutrition, and obesity during pregnancy and what it does to the foal. So first, undernutrition. So mares that were moderately undernourished, so said 80% of their needs during the pregnancy, we see no effects of in utero or early postnatal growth. Why? Well, it's because we see that the placenta is able to adapt. It will increase its vascularization, so more blood, more nutrients sent to the fetus. It will increase its own metabolism. So the placenta will increase its production of amino acid and vitamin, its transport of amino acid and vitamin to the fetus. So the placenta will be able to adapt because the undernutrition is moderate, it will be able to adapt to transfer the maximum nutrients to the fetus. So we don't see any difference in growth. But it doesn't mean that if we don't see any difference in growth, it doesn't mean that there is no difference. And actually, we see long-term effects of this moderate undernutrition. We see a delayed testicular maturation at 12 months of age, so it's the starting of puberty. We see altered insulin sensitivity at 19 months of age and a reduced cannon width. So we did not have the tools to study the density, so I don't know the density, but we measured the cannon width and we saw a decreased width of the cannons. From 19 to 24 months, we stopped at 24 months, so we don't know after. So even though we did not observe any difference in growth, we saw long-term effects of moderate undernutrition. If the undernutrition is severe, for example, when the mares were affected by Streptococcus equi during the pregnancy, they stopped eating completely. So the undernutrition was very severe. The author observed a decreased birth weight of the foals. And the they saw that the placenta tried to adapt because the area was bigger, but its volume was decreased, and also the surface of the microcotyledons, which is the exchange surface of the placenta, was decreased. So it looked like the placenta was not able to adapt to this severe undernutrition, which led to a decreased birth weight of the foals. But the long-term effects have not been studied, but it's pretty sure that there have been long-term effects on those foals too. So now what about overnutrition? So overnutrition during pregnancy that leads to obesity in late gestation has no effect on weight or size of the foals at birth. But at 2 months of age, in one study, they saw that the foals were lighter and had a smaller thoracic perimeter, which coincides with a decrease in milk production for those mares. But in another study, they see no effects on growth of foals at 3 months of age. So this is all we know right now, because the long-term effects have not been studied on other parameters for overnutrition during pregnancy. But if we focus on obesity from early gestation, so it mares that were already obese in early gestation, we know that those mares, they have an altered metabolism. They are insulin resistant, which precludes diabetes in other animals. And they have inflammation, low-grade inflammation, which is something that is usually observed in obese individuals. In early gestation, maternal obesity will affect how the endometrium, so the uterus, works. It will increase the inflammation and will increase the mitochondrial stress, so the oxidative stress in the endometrium. And same for the embryos. The author observed the increased inflammation, problem in lipid regulation and storage, and an increased oxidative stress in the embryos of obese mares. So obesity altered the uterine environment and the embryo development in early pregnancy. We had mares that were obese from 2 years before we bred them. So we decided to feed them the same amount of food per kilogram of body weight than the normal mares, and during the whole gestation. And so at birth, we saw no effects on foal, in utero growth. They had the same weight and size at birth, and they continued to grow exactly the same until 2 years of age. But we observed an increased inflammation in these foals at 6 months of age, and an increased insulin resistance at 6 and 18 months of age, as well as an increased numbers of foals that had osteochondrosis lesions at 1 year of age. So we saw that obesity, maternal obesity during the whole gestation, had an effect on the foal development that was pretty serious. So in conclusion, both under and overnutrition alter the long-term health of the foal. But okay, so we know that we have to feed the mare the good amount of nutrients, but what are the nutrients like? What are it's more starch, fat, proteins? What should we do? It is known, so from epidemiological studies and experimental studies that we did also, that feeding cereals to mares increase the risk of developing osteochondrosis lesions in the foals. So here you see 2 osteochondrosis lesions from my PhD. Actually, that one was pretty serious. That one is a foal that was born from an obese mare. But those studies, like when we do an experimental study, usually we choose one type of starch, one type of cereals, and one quantity. And the epidemiological one did not tell which quantity or which quality of cereals it was. They just said the mare received cereals or not. So it's very important to understand that we still do not really know if a type of starch is better than another one, a type of cereal is better than another one. And usually the quality of forage and the quantity of forage are not sufficient to meet the nutrients need in pregnancy. So the distribution of concentrated feeds remain important during gestation, because unfortunately we don't have pastures that are big enough to, and that have a biodiversity that is good enough to feed the mare as much as we want. It's very rare to have that. So the question is it possible to provide enough energy to the brood mares without affecting the health of their future foals? So we did two studies. So the first one, the mares received flattened barley during the last 4.5 months of gestation. So barley is pretty high in starch. So we had mares that receive only hay and haylage, so 0 gram of starch during their pregnancy, and the mares that received the flattened barley, and it was they received an average of 167 grams of starch per 100 kilogram of body weight per meal, and they received 2 meals per day. And in the mares that received the flattened barleys, we saw an increased number of foals that had osteochondrosis lesions. 45% compared to the mares that were fed only with forage during the pregnancy, 17%. Then we did another study, and unfortunately I don't have a lot of animals because we had technical problems and we could only focus on the males. So those are the results on the males. So both groups of mares received flattened barley during the 2 last months of gestation. One group received a maximum of 75 grams of starch per 100 kilograms of body weight per meal, while the other one received a minimum of 110 grams of starch per 100 kilograms of body weight per meal, still 2 meals per day. And you can see that the mares that received more starch produced foals, like 80% of foals had osteochondrosis lesions at 12 months of age. We could not follow them furthermore, but it's very interesting to see that the difference in amount of starch created this difference in the osteochondrosis lesions in the foals. But the limit of the presented studies is that usually diets that are richer in starch are also richer in energy. So was it just about the starch amount or the energy amount or the starch and energy interaction? So some people did a study. The mares were fed the same amount of energy during the pregnancy, but some mares were fed a diet rich in starch with more than 100 grams of starch per 100 kilos of body weight per meal, while other mares were fed exactly the same amount of energy, but mainly through corn oil, with 14% of fat and less than 50 grams of starch per 100 kilograms of body weight per meal. And what they observed is that the foals that were born from the mares with the high starch diet had an increased plasma glucose insulin concentration and an increased insulin resistance at almost like something like 5 months of age. So they did not follow the osteochondrosis lesions, but only on metabolism. You can see that adding fat will actually decrease the metabolic effects on the foals of the starch. So it may be a good source of energy to decrease the amount of starch in the diet of pregnant mares. But all fats are not born equal. And the quality of fat source is also important. The essential fatty acids and, like, for example, the long fatty acid, the polyunsaturated fatty acids, such as omega-3 and omega-6, have roles in immune, and they have immunomodulatory properties. They have roles in fetal neuronal development, in fertility, and in inflammation. And we need a good balance between omega-3 and omega-6 for the body to work correctly. We know that grass is very, very, very rich in omega-3, while cereals are richer in omega-6. So if you give too much cereals, you can debalance this balance between omega-6 and omega-3. This is exactly what's happening in humans right now. We ingest too much omega-6 in regards to the omega-3, and it can happen in horses too. So some studies have been studying the supplementation of diet with omega-3, and mostly through algae or fish source. There are less studies on linseed oil source, and I think it's a pity because linseed is a good omega-3 source of fat too. So in early gestation, supplementing the diet of mares with omega-3 will improve the uterine environment, especially if the mares are overweight, it will improve the uterine environment and then the embryo and the trophoblast, so the placental development. If it's if it's given in late gestation and lactation, it increases the omega-3 content in the milk and the transfer of omega-3 to the foals at birth. And some studies that have never really been published, but they have been presented in congresses, showed that it improved the social behavior, the memory, and the learning ability of the foals. And in stallions, it has been shown that it also improves the sperm quality. So if you choose a fat source, it will be better to choose a one that is rich in omega-3 to try to match what is in the grass and to try to rebalance the diet. No proteins and amino acids. So not a lot of studies have been performed in the pregnant mares for protein and amino acids. We just know that low protein diets leads to problems in fertility, but that's it. And in growing foals, excess of proteins does not affect the development of osteochondrosis lesions. So there is no problem with giving too much protein to the foals in regards to the bone and articular lesions. In other species, an inadequate intake of proteins has been shown to affect the behavior, the health, and the lifespan of the individual, as I showed yesterday. So it's still very important. We focused on L-arginine because, as I said yesterday, it's a very important, essential amino acid during the pregnancy and the growth of horses. And it's involved in a lot of different processes. And it's very abundant in mare's milk. Like, it's involved in protein synthesis, in vascularization, in the production of growth factors, and it can also be involved in the regulation of the metabolism. What has to be known for L-arginine is that it competes for the same transporter as lysine. So the balance between arginine and lysine should be really well conserved to be sure that you do not decrease the lysine absorption in the guts. So in early gestation, when the authors gave arginine to the mares, so around ovulation, they see a very few effects on embryo and fetus size, but they didn't look at anything else. So size is not the only answer, and we don't really know what it does to the embryo and the fetus. When it's given in late gestation, so during the last 4 months of gestation, we gave L-arginine to primiparous mares, because primiparous mares, they give smaller foals at birth, like they give birth to smaller foals that are this immature and that stay immature for a very long time. And it's because the placenta does not develop as well as in multiparous mares. And also, we know that the vascularization of the placenta is decreased in the primiparous mares. So we wanted to know if we can improve this uterine environment in primiparous mares with L-arginine. And we saw that we improved the glucose metabolism because we also saw that primiparous mares seem to be less able to adapt metabolically to the pregnancy, as I showed you earlier during this presentation. It increases the birth weight of foals born to primiparous mares, and it increases the placental gene expression of the glucose transporter and the fatty acid transporter in these placentas. So it may be useful to supplement the mares, but especially the primiparous mares, with L-arginine, but we really don't know the amount right now. When it's given in very, very late pregnancy, the authors observed an increased uterine artery blood flow. And that decreased the gestation length, but had no effect on foal and placental weight at birth. And when it's given during lactation, the authors observed no effects on milk composition, nor growth of foals, nor adiposity of foals. In humans, it is known to improve the sperm quality. So you can see that the quality of the main food that you give, so starch, fat, amino acids, proteins, it's very important. Like, it's not only just the quantity, but it's also the quality. So a short part on vitamins and minerals. Like, we don't know much about vitamins and minerals. For vitamin supplementation, I will focus on vitamin E and beta carotenes because this is what has been the most studied, and I think this is very important for the pregnancy. So when you supplement the mares with natural vitamin E, so organic one, during the last 3 months of gestation, you see an increase of vitamin E in the colostrum, the milk, and the plasma of neonatal foals. And vitamin E is very important for the antioxidation, for example. You see an increased quality of the colostrum with more immunoglobulin G and M. And you see also an increase in immunoglobulins in the full plasma at 3 days of age. So it sounds like it increases the quality of the colostrum and maybe the immunity of the foals. And if you give beta carotene to the mares from 2 weeks before foaling until 6 weeks after, you see an increased amount of beta carotene in the colostrum and the plasma of foals at 1 day of age. And this is very interesting because the grass in spring is very rich of beta carotenes, for example. But we don't know anything about the oocyte and embryo quality for those vitamins. They might be very, very important, but still we don't know. We also know that vitamin E improves the sperm quality in stallions. And it's also linked to the season, like stallions, they start to breed in spring. So it's very, very linked to the season, and it's very logical. So the supplementation of liposolute vitamins improves the colostrum quality and might improve the development of the foal thereafter. And we don't know the roles of antioxidants, and we know that they have plenty of antioxidants in the nature, and we don't know their role in placental, fetal, and long-term development in the horse yet. About calcium and phosphorus. When the phosphocalcic ratio is changed between 4 and 8 months of age in growing foals, you see that a high phosphocalcic ratio leads to a low phosphocalcic ratio leads to an increased number of osteoarticular diseases in foals. So during the growth of the foals, we know that the phosphocalcic ratio is very important for the normal development of the foals, but we don't know during pregnancy and lactation. We know it might be important, but we don't know the effects. For copper and zinc, we know that horses that have osteoarticular diseases usually have a low plasma copper concentration. It's occasionally because of zinc toxicosis, and usually we also see a low copper storage in the liver. And when foals are supplemented with copper between 3 and 9 months of age, you see that a low copper supplementation leads to 100% of the foals having osteoarticular lesions, while a higher copper supplementation with foals that have almost no lesions. So the copper deficiency is associated to the development of osteochondrosis lesions in foals, and it is very well understood. But do you need to supplement the mares or the foals? So this study studied 21 thoroughbred mares, some that were not supplemented and some that were supplemented 3 to 6 months before foaling with copper. Just as a reminder, the NRC recommendation are from 9 months of until 9 months of pregnancy of 0.2 milligrams per kilograms body weight, and then after that 0.25 milligrams per kilogram of body weight. So those ones were lower and those ones were higher than the recommendations. And then the foals themselves were either not supplemented or supplemented with copper. For maternal supplementation, you see a decreased number of lesions if the mother is supplemented, but you don't see any difference if the foal is supplemented. Then for the severity of the lesion, you see a decrease if the mother is supplemented, but you don't see any difference if the foal is supplemented. So it looks like it's better to supplement both mother and the foal to avoid copper deficiencies, but the mother are very, very important because it will increase the liver copper concentration of the mare, but also the fetus. And the foal, like the milk, copper concentration is very low. So during the first months, the foals will rely on their own liver copper concentration. the storage. So it's very, very important to supplement the mare with copper during the pregnancy, and with respect to the balance between copper and zinc, because too much zinc decreases the copper absorption. Right now, there is no study, no evidence that you should give more copper than what is recommended. For the selenium, we know that a selenium deficiency during pregnancy leads to the white muscle disease, which is a myodegenerative disease that affects the skeletal and the cardiac muscles, and that usually lead to death of the foal. So we know that we have to supplement with selenium, but we also know that the quantity and the quality of the selenium also does not have the same effect. So here's the first study is about the quantity of selenium. So they supplemented either 0.65 ppm or 0.35 ppm of selenium during the last 4 months of gestation. And they saw a increase of selenium concentration in the plasma and muscles of the foals, as well as the decrease in leptin plasma concentration just after birth, but no effects on visibly on the oxidative stress in those foals. Second study is a supplementation of 2 milligrams of selenium per day, but either seleniumethionine or sodium selenite. So either an organic form or more non-organic form during the last 3 months of gestation and the first months of lactation. And with the organic form, they see an increase in selenium concentration in the milk, as well as an increased concentration of selenium and specific alkaline phosphatase in the blood of foals at 30 days of age, and an increased blood glutathione peroxidase activity. So it looks like an increase of activity, antioxidant activity in the blood of those foals. So even the form of selenium affect differentially the development of the foals. So in summary, so for the starch, the recommendation is not to give more than 1 gram of starch per kilogram or 100 grams per 100 kilograms of body weight per meal, really maximum. But we don't really know about the quality of starch. It's best to limit the glucose insulin response in the mares right now. For the fat, you can give up to 14% of the concentrate feed as fat, and it's better to use an omega-3 rich source of fat. For the proteins, follow the current recommendations, really. And we don't really know the role of these essential amino acids, and we need to study more them to see if one would be better, like if we need to enrich one or another one. For the vitamin and minerals, so I give the numbers for vitamin E and beta-carotenes, but we don't really know about other vitamins right now. For the minerals, so I was very focused on calcium, phosphor, and there is an error here. It's copper and zinc, and selenium. But we often we receive the question about the seaweed supplementation for the iodine, and I don't think it's a good idea because it's very, very, very high in iodine, and you can give too much of iodine, and it's not a good idea. What about the long-term effects of the vitamin and minerals and everything? We don't know. We really should study it more. So now, how to assess the adequacy of the environment? So first, it's by monitoring the body condition. I'm not the first one to tell that, but it's very important to be sure that the mare is not either under or overnourished during the pregnancy. How? Well, through the body condition score, as Other presented earlier. The pregnant mare is a bit particular because you see conformation change during the pregnancy, and especially musculature stretch, especially in the rump and in the ribs. You see it stretches, so it's harder to assess the body condition of a pregnant mare. So it's better to focus on the shoulder and the withers to assess the body condition of a mare. There is also a Christine score that has been published. So it looks like it's linked to maternal insulin resistance, but studies have to be really more But there is this Christine score that can be useful also. Does it predict the full metabolism? Well, somewhat. You can see that the correlation coefficient is quite low, but you can see there is still something. So mares with lower body condition score have foals that have a higher insulin sensitivity. But in our study, we did not have very, very underweight mares, so we don't know where it goes. And from one of our studies, we can predict that it might go like that, actually. So it might predict the full metabolism, but not so well, actually. Just as an example, you can see here the French National Stats stated an application for the body condition score. So here is the link if you want to access it. It's in French, but it's very well made. It's a very good tool. So how could you also monitor the body condition of the mares through ultrasonography? So you need an ultrasonograph. Here we use the one that we use for the concept of gestation for the mares. So it's a very basic ultrasonograph instrument. Usually the measures are made at the rump, and here you have between the gluteal biceps and the semitendinous, you have depression here. So we measure the depth of fat here. So here you can see a very lean mare. So it's only here that you see fat. Here you see a mare with an optimal body condition, and here you see an obese mare, and you see that the fat started to invade the muscle, actually. We can measure on other sides for the ribs, for example, but right now it doesn't correlate very well with the metabolism of the foals, and we need to do more studies to be sure that it works well. And you need an ultrasonograph. Really, I think the body condition score is better. So know how to monitor the metabolic health of the pregnant mares, because a mare that is insulin resistant will have an increased risk of producing foals with osteochondrosis lesions. We know that. And all the basic analyses that you can make, so like basal fasting glucose, insulin concentration, or all the proxies that you can calculate from that, do not correlate with either the full metabolism or the osteochondrosis lesions. So I'm talking to the vets and the vet students right now. You need a more complex and complete methods to assess the maternal metabolism. And those methods are, like, you have a lot of them. I will talk about those two, one IVGTT and FSI-IVGTT. But you have a different kinds. The glycemic hyperinsulinemic clamps are very, very heavy. So the IVGTT, or intravenous glucose tolerance test, it's a test where you first fast the horse. So the horse can drink but not eat for at least the last 6 hours before the test. Then you draw a first blood sample when the foal is fasted. Then you inject an intravenous glucose, or you can either inject it, or you can also, if you change intravenous to oral, you can also give it by the mouth. And then you draw blood for 3 hours after. And you will normalize over the fasting concentration of glucose and insulin, and you will calculate the area under the curve of glucose and insulin plasma concentration. It will give you the glucose clearance and the insulin release. So it's interesting, but it's still very, like, the calculation that you can make from it are very, very basic. Like, you don't really have a very good quantitative way of knowing how the horse is doing. For that, you have the FSI-GTT, so for frequently sampled intravenous glucose tolerance test. It's a little bit more complicated. The horses are allowed to eat hay and drink water. So you do a basal sampling, and then you do a glucose injection exactly like the same. And then you do first samplings for the first 19 minutes. And then you inject insulin at the 20th minute. And then you do blood sampling for 3 hours. And you will be able to calculate the to estimate simultaneously the insulin sensitivity and the glucose tolerance. So you will have a lot of indexes that will be calculated through a black box mathematic model. You need a software, but it will give you the insulin sensitivity and other very interesting indexes for the horse. So what about maternal insulin sensitivity? So we know that insulin sensitivity decreased and the glucose absorption increased during pregnancy, also the pancreas insulin production. But we also know that there are differences between the breeds and between the seasons. In our own French Anglo-Arabian mares herd, we saw that if the mares had an insulin sensitivity below 1 in late gestation, they had foals that had an increase of osteochondrosis lesions. But right now we need to develop the reference charts according to the stage of gestation, the age, the purity, and the breed of the mares. So it's interesting, but it's not still yet that. What about the full insulin sensitivity? It's not predictive at all. For example, here we have the foals born to mares fed with forage only or forage and barley, and you can see that we see an increased glucose tolerance for the foals born from mares fed with forage only at 3 days of age. But then at 19 months of age, the contrary, we see a decreased insulin sensitivity. So it's really not predictive. Same for our foals that were born to obese or normal mares. We see decreased insulin sensitivity when the foals are in pasture, but we see nothing when the foals are in stable. So it's really, really not predictive. What about the maternal systemic inflammation? So maternal insulin resistance is correlated to the systemic inflammation. It is well correlated, actually. And we know that maternal and placental inflammation, as you can see here is the inflamed placenta. You can see that the arteries are very, very small. And here you see a normal placenta with big arteries, like the blood can really flow here. So the mother that have a higher level of serum amyloid A during late gestation, they produce foals that have more osteochondrosis lesions too. What about the measurements of the placentas and the foals at birth? Well, you can weight the placenta and the foals at birth. You can measure the surface, you can measure the volume. It's easy, you don't really need any tools to do that. They are not good predictive markers of how the foals will develop. Moreover, you have to know that those measurements are very strongly correlated to the maternal withers height. They are decreased in premenopausal pregnancy and in very young and old mares. But it's very important to examine carefully the placenta, because if you see any missing part, any white patches or abnormal coloration of the villus side, it's a bad sign. It's not a good sign, and you need to call the vet. But when the measurements strongly differ from expectation, for example, when you have a fetal growth retardation, so it's foals that are very, very tiny and very, very light compared to the normal foals, it affects the metabolism, the osteoarticular development, the reproductive maturity, and the cardiovascular functions of the foals. On the contrary, if you have an overgrowth of the foals, so very big and heavy foals, it affects the metabolism and the cardiovascular function too. What about the growth rate of foals? An increased growth rate is linked with osteoarticular disease. When the foals grow too fast, they have a higher risk of having osteoarticular diseases. But a normal growth rate does not mean absence of osteoarticular diseases. Here you see foals that grow exactly the same, but here you see more osteochondrosis in the red group, and here you see more osteochondrosis in the orange group. So a normal growth does not mean that the foal growth is actually good. So in summary, the different things that we can measure, the different tools that we can use. For me, for assessing the body condition score is the best right now. For the metabolism, so the basal measures are not good. You can use complex measures, but we need to develop references. The metabolism of the foal is not a good predictor of what it will be at adulthood. And during birth and growth, the placenta is not a good predictor, but you really need to check. And for the growth, like a fast growth is predictor of osteochondrosis lesions or other osteoarticular lesions, but a normal growth does not predict absence of lesions. So the last very, very small parts. So is it the same for all mares? Well, the obvious answer is no. So we know that there are differences in breeds. The breeds that we call easy keepers, such as ponies, Arabians, Iberic horses, we know that they naturally have a lower insulin sensitivity than warm-blood horses. But we also know, for example, that ponies are less affected by osteochondrosis lesions than warm-blood horses. We also know that the placental function differs between breeds. So all breeds we might not need to feed all the mares from the different breeds the same. Also, we know that parity and age of the mares will also affect. For example, we know that the primiparous mares seem to be less able to metabolically adapt to gestation and as much as they grow older, actually. We know that the foals born to primiparous mares are smaller and less mature than foals born to multiparous mares, and that all mares can have altered placental functions. So those mares might need more support, more nutrition support than a normal age like 8 years old multiparous mare, for example. And we also know that the season can affect that. So for the mares that are bred in season that will have access to more nutritious pasture, it's okay. But if the mares are bred out of season, they will really, really, really need a vitamin supplementation more than the mares that are bred in season, actually. Even if mares bred in season need supplementation too. So as a conclusion, we know that the nutritional programming interacts with all those different factors and with the genetics to affect the health, the longevity, and the athletic and reproductive performances of the foals. So it is very important to understand what are the critical periods of development in the horse. If you work in the industry or if you're a vet, to support the people you work with either tools, as I showed you, or accessible information, because it's important for everyone to understand what's going on and what's important. Forage should be the basis diet for mares and foals. It's pretty evident. You have to know that vitamin and minerals in excess can be as detrimental as deficiencies. So really stick to the recommendations. And parity, age, breed, season, and location may affect the effects of early nutrition. So what are the tools that we can use? So it's body condition score, placental examination, and also the quality of colostrum. I didn't have time to talk about that, but a poor colostrum leads to more osteoarticular lesions too in the foals. So all of those are easy to assess. Quality of colostrum, you can use a refractometer to assess that. It's not very expensive. It's very easy to assess that. And for the foals, the body condition score is also important to assess, even if it's harder on a foal. And the growth rate is also important to follow. So I just want to thank especially my PhD lab and especially Pascal Schwad-Palmer, that was my PhD supervisor, for all that I presented to you today, and my lab that I'm working with right now in Canada, and all the financial support that we'll be able to get from the French National Studs and INRAP. And thank you everyone for your attention.
Dr. Morgan, thank you very much for a wonderful talk with a lot of information, a lot of information. I think everybody will be amazed at everything that you have studied and everything that has been studied. Very, very enlightening, very, very interesting. I have received lots of wonderful comments on your presentation. And many people are asking for your email because they want to read your work. So I don't know if you can put your email in the chat, please. Oh, there it is. Ahí está la información del correo electrónico de la doctora Morgan.
And I can put my ResearchGate page too, because all the papers are there.
Okay.
And you can request the papers if you can't access them too.
Okay, thank you very much. Para todos los que han pedido el correo de la doctora y su página, entonces ahí pueden encontrarla, por favor. Thank you very much. Since I have you here, I have a few questions, if you don't mind. One of the questions was the type of oil that you were using for your research? Was it sunflower oil, corn oil? What was it?
For the research that I presented?
Yes.
The people that studied oil, for the energy study, it was corn oil, which is rich in omega-6. But it still shows something interesting. We did not give any oil to the mares, actually, because we were really focused on the starch amount.
Okay, okay. And another question about the oil. Could the use of polyunsaturated fats be a strategy for pre and postpartum?
Yes, so I think so. There are a few very, very early studies that show that it can improve the quality of the colostrum as well. And I think it's very important because also normally the mares, when they give birth in season, they give birth in spring, and the grass is very, very rich in omega-3 at that time. So I think it's important also to prepare the milk quality and to help for the foaling. Yes.
Okay. And two more questions. I think, this question has been answered by everything that you have said so far, but somebody wants to know if obesity then will have a repercussion in the tending and birth of the foal.
So we don't see for the birth itself. So for the birthing, we don't see any difference between obese and non-obese mares. The foals, the birth is as fast. The foals are not bigger. It's not like with the cows. There is no difference for the foaling. Well, we have pretty very obese mares, but everything was fine. But yes, it will still affect the development of the foals, and I am pretty sure because we see the same effects on the horse that in the humans, that we also see effects on the reproductive function, and we will also see effects on the second generation.
Okay, thank you. I have a question here that asks about the amount of starch for the lactating mare.
This is a very good question, and we also wonder about that. For me, it's more like if you respect the 100 grams, you would be fine because it's right now we know that it's like really going over this threshold will really affect the metabolism of the mare, but it's just what I can recommend right now.
Okay, thank you very much. Then there's another question about the retention or impaction of the meconius. What can you tell us? Is it due to nutritional deficiencies?
This I have to say that I really don't know. I can't answer.
I'm going to see if Dr. Santiago García Pasquel can answer that question. Do you know anything about that? ¿Sabe algo usted, Dr. García Pasquel, sobre la retención del meconio?
Hay pocos reportes hay más reportes acerca de conformación como la causa, porque también existe una predisposición en machos que en hembras. Estadísticamente la pelvis de los machos es más estrecha que la de las hembras y nutricionalmente no se ha hecho una correlación entre la impactación y la alimentación de la madre. Hay que recordar que esto es inmediatamente después del parto, entonces tendría que haber alguna correlación entre la alimentación de la madre y esta presentación, y no hay en la literatura ninguna evidencia que correlacione o que vea como causa la impactación de meconio con algún problema o alguna deficiencia alimenticia durante la gestación.
Muy bien, muchísimas gracias, doctor García Pasquel. Continuando entonces con usted, también tengo varias preguntas. Una de ellas es de la doctora Masri, de hecho. Ella pregunta que, bueno, ella hace la siguiente reflexión. La receptora tiene el potro más pequeño y me imagino que aquí es la pregunta, ¿se sabe si cuando llega a ser adulto es igual que su hermano que estuvo en un vientre más grande? Cuando son adultos.
Hay un estudio, sí, hay un estudio interesante con embriones de transferencia de embriones que son hermanos genéticos, mismo padre, misma madre, transferidos a diferentes receptoras con diferentes características de útero. Y el potro al nacimiento muestran cierta disparidad. Estos animales que se encuentran bajo condiciones de salud detectable normal, más o menos para entre los 8 y los 18 meses, llegan a nivelarse y tener una altura, la misma altura al final del crecimiento, lo que se llama la parte del crecimiento compensatorio, que es entre los 300 y 600 días posparto. Ahora, ¿qué es lo que sucede si hay una disparidad muy grande, donde ya no hay, por ejemplo, lo que decíamos de las razas pesadas haciendo transferencia de embriones a razas más pequeñas, no va a haber esta compensación? O sea, si nosotros transferimos, por ejemplo, un percherón a un cuarto de milla, pues vamos a tener un percherón de menor tamaño y por más que tenga compensación, no va a llegar al mismo tamaño. Entonces, incluso esa es ¿por qué la tendencia ahora de utilizar yeguas receptoras que son más grandes que la madre y con úteros más grandes que la madre para potencializar la realización de esta genética que trae el animal?
Muy bien. Muchísimas gracias, doctor. Hay una pregunta sobre la leche de mula. Si existe alguna referencia, si hay literatura sobre esto y cuál es su opinión sobre el uso de las mulas como receptoras desde el punto de vista de la lactancia.
Bueno, o sea, como receptoras de embriones, honestamente, depende todo del lugar donde estemos y la disponibilidad de animales que tenemos. Si lo único que tenemos son mulas, pues la recomendación siempre es utilizar un animal del mismo tamaño o más grande que el que se está reproduciendo. Ahora, la utilización de mulas, a menos de que tengamos una disposición y a nuestra disposición una cantidad de mulas grande, lo cual me parecería extraño, pero siempre la recomendación es utilizar la misma especie, ¿no? Y animales que sean de vientres más grandes, que sean animales más grandes, y vamos nosotros a hacer la transferencia de caballos de caballo a caballo. En un medio ambiente de investigación, a lo mejor podríamos tratar de hacerlo, pero la recomendación siempre es utilizar la misma especie para tratar de mantener todo controlado y utilizar animales que sean más grandes, ¿no? Cosa que a veces con las mulas, o sea, el tamaño de las mulas comúnmente es más pequeño que el de un caballo grande, ¿no? O sea, un warm blood no lo transferiríamos a una mula, sino transferiríamos a un caballo warm blood o a un animal más grande, ¿no?
¿Y sobre la leche de mula?
Sobre la leche de mula, hay de hecho, ahorita lo estaba buscando, perdón, hay un conjunto de artículos científicos que se llama Nutrition and Feeding of the Broodmare, que fue publicado por la EAAP, que es la publicación 120 del 2006, donde viene muchísima información, tanto leche de burro como leche de mula. Entonces les recomiendo buscarlo. Vienen muchos artículos, incluyendo los artículos de la doctora Robles.
Perfecto, muy bien, muchas gracias, doctor García. También para usted, ¿qué método recomienda para evaluar la calidad de calostro y leche en el campo?
En el calostro, la calidad del calostro, yo lo que recomiendo es un refractómetro de grados Brix, que es el que se utiliza para miel y vino, que llegue hasta 30% de grados Brix. Lo pueden comprar por internet, tienen un costo muy bajo, oscilan entre los 15 y $25. Es algo que pueden utilizar en campo para evaluar el calostro inmediatamente al nacimiento. Hay que recordar que es lo que se recomienda es que tenga 30% más de grados Brix para considerarlo un calostro de alta calidad. Y la evaluación de la leche, desafortunadamente, esa parte sí es compleja. ¿Por qué? Porque se necesita un cromatógrafo para saber exactamente la composición de la leche. O sea, podemos hacer nosotros una evaluación física viendo qué tan espeso es, qué tan diluido está, qué capa grasa tiene, pero ya llevarlo más allá de eso sí requería, o sea, ya muy específico para saber la cantidad de ácidos grasos, etcétera, se tendría que hacer un análisis cromatográfico para saber exactamente qué es lo que tiene.
Y dando seguimiento a lo de las mulas, pregunta que sí pueden quedar cargadas, ya que son una cruza.
Honestamente, yo no tengo experiencia haciendo transferencia hacia mulas. O sea, sí tengo experiencia donde embriones de mula han sido depositados en caballos y sé que la doctora Boeta hizo bastante estudios en la transferencia de embriones y creo que sí logró que llevaran a término, pero creo que no fue algo muy, ¿cómo se llama? Continuo, entonces exactamente los remitiría a las investigaciones y publicaciones de la doctora Boeta sobre mulas y burdéganos y la transferencia de embriones, que publicó creo que en 2012.
Aquí hay un comentario, Ana María Ríos indica que en su práctica profesional ha detectado que cuando un calostro es de baja calidad se presenta retención de meconio.
Hay que recordar que lo que sucede es que la retención de meconio está asociada a varias cosas, ¿no? O sea, hay que recordarnos que hay que diferenciar muy bien entre correlación y causalidad, ¿no? Si nosotros tenemos un calostro de baja calidad, hay dos cosas. Puede ser la edad de la yegua o puede ser el estado fisiológico o incluso de enfermedad de la yegua. Entonces, o incluso de la placenta. Entonces, no es necesariamente porque el calostro sea de baja calidad haya retención de meconio, sino puede ser porque el potro traía una infección, por ejemplo, una placentitis, nació con algún grado de deshidratación o incluso alguna afección incluso de oxigenación del intestino. Todos estos van a afectar la expulsión del meconio, porque obviamente si tenemos un desbalance volémico, va a haber una extracción de líquido, va a haber menor motilidad intestinal, va a haber menos expulsión y al mismo tiempo puede haber un calostro de mala calidad. No por tener un calostro de mala calidad necesariamente vamos a correlacionarlo con una expulsión de meconio, porque no todas las yeguas que tienen calostros de mala calidad tienen potros con retención de meconio, ni todos los potros que tienen retención de meconio tienen problemas con calostros de mala calidad. Entonces hay que recordarnos que tenemos que ver el caso como completo y comúnmente los potros que tienen problemas al parto y problemas placentarios sí pueden presentar retenciones de meconio, no necesariamente asociadas al calostro, sino al problema principal que fue un problema placentario.
Muy bien. Siguen las preguntas con las receptoras grandes. Dice, ¿qué referencia hay como lactantes? Puede ser... Adelante.
Sí, como les había mencionado en la gráfica, de hecho, o sea, las yeguas grandes producen más leche porque la producción de leche es por kilogramo de peso. Entonces, obviamente, una yegua árabe que pesa 300 kilos no va a o 400 kilos, por ejemplo, que es muy finita, muy delgada, no va a producir la misma cantidad que una yegua percherona que pesa 800 kilos. De entrada, la ubre es más grande y la cantidad de sangre que puede circular por unidad de ubre es mucho mayor, además del peso. Entonces, como vimos, las yeguas percheronas siempre van a producir, y las razas pesadas siempre van a producir más leche, incluso hasta el doble que una raza más ligera, ¿no? Como un árabe. Entonces, eso lo tenemos. Y la otra es físicamente el útero es más grande, ¿no?
Dando seguimiento a esa pregunta, decían, puede ser que algunas no sean buenas lactantes o presenten insuficiente alimentación comparadas con receptoras de tamaño medio. ¿Qué pasa en el crecimiento de esos potros?
O sea, si nos vamos a lo global, la mayor parte de las razas pesadas producen más leche, ¿no? En el general. Si ya nos vamos a lo particular, seguro, o sea, es seguro, hay yeguas que son de razas pesadas que no producen buena leche porque tienen alguna alteración metabólica o algún problema en su ubre, ¿no? Entonces, estas yeguas sí van a tener un problema y de hecho, o sea, lo que nosotros tenemos que entender es un cambio por la otra, ¿no? ¿Por qué no todo el mundo está utilizando percheronas para hacer yeguas receptoras? Porque cuestan más y comen más y defecan más y todo cuesta más, ¿no? Entonces no es solamente, o sea, y sí, nos van a dar potros más grandes, pero también el costo de manutención es más grande. Entonces, por eso es que no todo el mundo lo está utilizando, pero por ejemplo en Estados Unidos se utilizan mucho cruzas de yeguas de tiro o yeguas de tiro como receptoras, porque la alimentación es más fácil porque hay mucho más espacio y están libres, ¿no? Entonces, por eso se manejan. Ahora, ¿qué es lo que sucede con los potros de yeguas de este estilo, que son yeguas de tiro o yeguas de razas pesadas, que tienen problemas de lactación? Sí son un problema porque la alimentación suplemental de esa cría va a ser mucho mayor. O sea, no es lo mismo alimentar un potro de 30, 40 kilos, alimentar un potro de 60, 70 kilos con leche artificial, ¿no? El costo también se dispara mucho y los volúmenes también se vuelven mucho más grandes, pero también se puede hacer al igual que una raza más pequeña, ¿no?
Perfecto. Quiero hacer un breve comentario. Vamos un poquito atrasados, pero todavía tenemos algunas preguntas. Entonces, quizás podríamos recorrer un poquito el tiempo del receso, al menos para hacer dos o tres preguntas al doctor Velázquez Cantón. Entonces, ¿está bien?
Sí, de acuerdo, ningún problema.
Perfecto, muchas gracias. Entonces, doctor Elías, un caballo que sufre una lesión musculoesquelética debe tener un cambio en su dieta con mayor proteína o aminoácidos.
Hola, buenos días. Bueno, lo primero que tendremos que revisar es qué tan fuerte es la lesión, ¿no? Es decir, si a lo mejor fue profunda, pero definitivamente tenemos que revisar el peso del caballo. Entonces, depende dónde fue la lesión, si en los anteriores o en los posteriores. Los posteriores hay más peso. Entonces, por el simple hecho de tener una lesión, recordemos que el cortisol se eleva. Va a haber una baja de peso inmediata por el caballo. El propio caballo, independientemente si es fuerte o no la lesión, recordemos que el caballo tiene el umbral de dolor más alto dentro de los animales domésticos. Entonces, es muy probable que él solito baje de peso, pero sí tendríamos que hacer ajustes en la dieta. Me hubiera gustado saber cuáles eran los ingredientes de esa dieta, pero recuerden que un caballo que ya no realiza actividad física, se recomienda o disminuir significativamente el concentrado y que la dieta sea más en forrajes, pastos y leguminosas de excelente calidad. Porque no podemos estar alimentando a un caballo con concentrados, y muchos concentrados son inseguros, en caballos que tienen lesiones o que están encerrados.
Muy bien, muchas gracias. Otra pregunta. Respecto a las curvas de crecimiento y ganancia de peso diaria, ¿por qué no se agrega la alzada como un factor a considerar? Ya que puede que tenga potros que van creciendo de acuerdo a la curva, pero la realidad es que solo están aumentando en condición corporal y no en altura, es decir, están engordando.
Sí, y tiene mucha razón y nos faltó poner eso. Efectivamente tenemos que medir la altura de piso a la cruz, igualmente ir haciendo nuestros parámetros, así como vamos teniendo el peso, es decir, tenemos que hacer 2 columnas, el peso del día 1 con la medición de la altura. Seguramente a caballos adultos pues ya llegaron a lo que tendrían que llegar, ¿no? Pero sí, evidentemente, otros destetados, hacer todo ese seguimiento, precisamente. Porque recordemos que al año los potros deben de alcanzar aproximadamente el 80% de su peso vivo adulto y el 50% de la altura de animales adultos. Aproximadamente.
Muy bien, muy bien. Otra pregunta. Si se formulara en función de la concentración de aminoácidos esenciales, ¿se debería seguir usando el mismo nivel de proteína cruda en las dietas de crecimiento?
No, porque evidentemente ya estás tú ofreciendo una calidad de proteína. Entonces, la cantidad que tú le tendrías que estar ofreciendo ya sería menor. Es lo que ponemos en el ejemplo. Por ejemplo, el 21% de proteína quiere decir que por cada kilo que tú le estás dando son 210 gramos de proteína. Versus el otro, que tiene 14% de proteína, son 140 gramos por cada kilo que tú le estás dando al caballo. Pero como tenemos que ver la calidad de los aminoácidos que componen la proteína, evidentemente tienes que dar mucho menos cantidad. Entonces, ese es el beneficio de cuidar las cantidades.
Perfecto. ¿Un caballo adulto de 16 años aún puede generar masa muscular si se modifica su alimentación y ejercicio?
¿Sí? Sí, sí y no, es que habría que ver, porque recordemos que tanto las fibras musculares, conforme va avanzando el tiempo, y se acuerdan también de las células satélites, esas también se van atrofiando conforme va avanzando la edad. Y un ejemplo rápido, todos los astronautas que se van al espacio, muchos de ellos sufren lesiones musculares importantes porque no están haciendo ejercicio, entonces están todo el tiempo flotando. Y muchos de ellos, hay estudios bien interesantes donde las células satélites están atrofiadas, aún siendo personas jóvenes. Un pequeño ejemplo. Pero bueno, ya hacia los animales viejos, depende de la calidad de vida, ¿no? Es una yegua ya adulta, biológicamente puedes encontrar animales hasta de 25 años, caballos, muy bien, pero habría que valorar primero la calidad de vida que ha tenido esa yegua, y si se está comentando que a los 16 años ya tiene una baja de peso muscular importante, entonces quiere decir que a lo mejor no ha sido alimentada y nutrida de manera adecuada. Pero sí podría tener una mejoría si se le da aminoácidos de calidad. Sí puede haber una mejoría.
Muy bien. ¿Qué suplementos recomendaría para ayudar a la formación y crecimiento muscular en caballos deportivos?
¿Qué suplementos? Bueno, más bien son complementos, porque tú los adhieres a la dieta. Es decir, porque suplemento tú quitas algo para poner algo. Entonces sería un complemento. Pues en el mercado hay varios, ¿no? Digo, la verdad es que aquí sí cuidamos mucho el tema de marcas, y no por ningún tema importante, sino porque pues respetamos, ¿no? a toda la industria. Pero bueno, pues, si quieren mejor, pues eso lo podemos ver las marcas ya con un correo.
Entonces, una última pregunta, one last question, and that is for you, Dr. Morgan. The question is, if a mare becomes pregnant during the heat of the fall, is it possible that the young that is developing suffers from osteochondrosis problems?
So for the effect of lactation, basically, if the mare is in lactation when she is pregnant again, right now we don't know, but we are studying that. So maybe we'll come very soon with some answers.
Thank you very much. Thank you very much. Tenemos otras preguntas que trataremos de que se puedan contestar un poquito más adelante. Les agradecemos mucho por todo su interés y su participación. Hay varias preguntas que tienen que ver con qué se da primero, si el concentrado o la alfalfa. Yo creo que los puedo referir a la plática de ayer de la doctora Meriel, porque ella abordó muy bien esa situación. ¿Sí? No sé si alguien quiera comentar algo rápidamente o yo lo puedo hacer.
Bueno,
Adelante, doctora.
Algo. Recordemos que son herbívoros los caballos. Entonces, en la naturaleza no existían los concentrados. Entonces, la respuesta es sencilla. Primero forrajes, mi punto de vista.
Así es, y lo comentó muy bien la doctora Meriel ayer. Primero los forrajes y después los concentrados. Y eso tiene que ver con la digestibilidad del almidón, que el almidón necesita ser muy bien digerido, y el caballo lo puede hacer en su intestino, pero necesita tiempo. Si se pone primero el concentrado, los granos, y después el forraje va a empujar, va a aumentar ese peristaltismo, no va a tener suficiente tiempo de digestión el almidón en esos granos, y ese almidón va a parar en el colon, y entonces en el colon viene el proceso de fermentación y todos los problemas asociados con una fermentación masiva del almidón y que puede conducir a cólicos, ¿no? Entonces, la respuesta sencilla es primero forraje y después concentrado. Bueno, muy bien. Muchísimas gracias a mis ponentes. Thank you very much, Dr. Morgan, Dr. García Pasquel, Dr. Velázquez Cantón, for your participation here. It was a pleasure to have you all here. Dr. Morgan, thank you very much again for being with us. Gracias a todos. Tenemos un pequeño receso que se van a recorrer 10 minutos los tiempos. Son prácticamente las 12. Nos vemos a las 12:10. Muchísimas gracias.